Hello and welcome to section 13.7, which is on modeling randomness. So my example, a teacher wishes to choose 3 students from a class of 25 students to raise the school's flag. What numbers should the teachers choose based on this line from a random number table? So I have 50 numbers here, and the reason I have 50 is because there are 25 students, and because some of them are going to be 2-digit numbers, they all have to be 2-digit numbers. So there are 50 numbers here broken into 2-digit numbers. There's 25. Okay, so I need to look at each 2-digit number, and since the key number there is 25, I'm going to be looking for numbers that are less than 25. Okay, so I have a 65, a 35, an 87. Remember, I'm looking at every two digits. So 4 is less than 25, 69, 87, 14, 98, 95, 9. And I can stop right there because I just need the first 3, right? You're choosing them randomly. So the first 3 numbers that are lower than 25 are the 3 kids that get chosen. And remember, this is all based on randomness. So it's just, this is a simulation that you could use. A random set of numbers, okay? A random series of numbers, and then you just base your successes based on your numbers that you're talking about. I want 3 kids out of 25 students. So the first 3 numbers less than 25, I mean, how much more random do you get than that? Just a random set of numbers. You pick the first 3 that pop out of there that are less than 25, and there you go. Those are the 3 kids that get picked. So if their numbers are 4, 14, and 9, they get chosen to raise the school flag that day. Again, it's all based on chance here. It's just random. Expected value is the sum of each outcome's value multiplied by its probability. And so I have an example here to calculate expected value. And to do that, I have a little formula here. So it says if A is an event that includes outcomes A1 or A, A2, A3, and value A to the n, whichever that might be, it has to be a quantitative value associated with each outcome. The expected value of A is given by the probability of A1 times the value of A1 plus the probability of A2 times the value of A2, and on and on and on and on, depending how many different values you have. Okay? So I have an example to go with this. You earn 1 point for each correct response on a multiple choice test and lose 0.5 points for each incorrect guess. Each question has 4 answer choices. If a student doesn't know the answer and guesses, what is the expected value of the guess? Okay, so to do this, you have to break each one down. Okay, so my probability of A is getting it right? So I get 1 point for that, and the probability of that happening is, oops, didn't mean to do that. The probability of that happening is 0.25, right? Because only 1 out of 4 answers is correct. So I'm going to take 1 times 0.25 plus 0.25, because you have a 1 in 4 chance of getting it wrong, and you have to take that times the negative 0.5 points. And since there are 4 choices, I have to do all 4 of them. So, oops, negative 0.5 plus, I have another 0.25 times negative 0.5 plus, I have 1 more of those. 0.25 times negative 0.5, because there are 3 chances that I could get it wrong and only 1 that I could get it right. Okay, so then 1 times 0.25 is 0.25. 0.25 times negative 0.25 is negative 0.125. And then I'm going to have another negative 0.125 plus another negative 0.125 from multiplying these all out. Okay, so I have 0.25 plus a negative 0.375. So my expected value of that guess is negative 0.125. It's negative because obviously you have 3 chances to get it wrong and only 1 to get it right. So it's a guess, and this is just a calculated expected value for each guess. Okay, obviously sometimes you guess it right, but you have a way better chance of guessing it wrong. So bring this knowledge with you about modeling randomness and calculating expected values, and we'll talk about it more the next time I see you. Have a good night.